Appreciate everybody coming. It's cold outside. It's wet. It's December. It's 12 days before Christmas. And I appreciate everybody coming. Glad to see you all here tonight. So my name's Rob. I organize Idea to IPO. We've been doing events in Silicon Valley for a number of years. We hold events multiple times a week from San Jose to San Francisco. We always have a busy calendar of events. I'd like to highlight just a couple that are coming up. So next Tuesday, December 20th, we have an event called Latest Innovations in Gaming Technology. That's at Parisoma in San Francisco. And on Wednesday, the 21st of December, yes, that's 4 days before Christmas, that's an event called, it's a venture panel discussion, 2016 in review, and what's ahead in 2017. That's at the Cuckoo's Nest. That's just a mile from here. So check out all the details on our site, ideatoipo.com. We were launched officially on February 1st, 2010. At that time, we had no members, no events on our calendar. At this stage, we have over 40,000 members with all our meetup groups in the Bay Area. We've completed over 1,675 events. By any standard, by any measure, we're the most active, most prolific startup event organization in Silicon Valley, bar none. I like this crowd. Man, you guys are good. But let me expand on that. So if we're the most active, most prolific startup event organization in Silicon Valley, and Silicon Valley is the global center of innovation and entrepreneurship, that would make us the most active, most prolific startup event organization in the entire world. Yeah. I like you guys even more. Our mission is to promote entrepreneurship, support entrepreneurs, build community, and provide value in the Silicon Valley startup ecosystem. To that end, we provide content that is practical, actionable, and relevant, stuff that you can actually use to succeed as entrepreneurs. We believe in community because Silicon Valley is an aspirational ecosystem. It attracts people from all over the world who come here to do great things. Who here is not originally from Silicon Valley? Cool. Who was born and raised in Silicon Valley? Not just you guys? Okay. Whether you're a native or you got here last night, it's important for us that we provide multiple channels for you to meet people, build relationships, grow your network. To that end, we have a regular TGIF, that's Thank God It's Friday, mixer every few weeks at the Hyatt Regency Santa Clara. It's hosted by CJ Terrell, one of our team members. Let's hear it for CJ.
Hi everyone, I'm CJ. So first off, I'm amazed that that many people are not from the Valley originally. That's pretty cool. Reason why I say that is because, as Rob mentioned, I host TGF mixers every about 2 to 3 weeks, and they're really good ways to come out in the community. A lot of attendees we find are actually those who are not from Silicon Valley. And it's, again, a really neat way to connect with investors, connect with people who are in their beta stages of their startups of all different industries, from healthcare to AI to almost anything you name. Just personally, I've been doing them for a while, and I've met people probably from about 40 to 50 countries that have come in, left, stayed in the Valley for whatever reason. You get to learn a lot of really neat stories from everyone who attends. Our next one's going to be on December 23rd, 2 days before Christmas. So if you are in town, I highly recommend you come on over. It's going to be, again, on the 23rd from 8 to 11 p.m. at the Hyatt Regency in Santa Clara, and they are free. Hope to see you there. Thanks.
With regard to value, it's important that we provide value at each and every one of our events, not just value for your money, which is important, because we know a lot of entrepreneurs are struggling. So that way, because of that, we price our events so that they're affordable, and we make sure that we have a decent meal at all of our events. Is this meal decent?
Yep. Good.
For that, we want to thank Sherman and Sterling. Let's hear it for Sherman and Sterling for the meal. Don't get too used to it. Next week, it's back to Costco pizza. More importantly than your money, though, we want to make sure that you get value for your time, which is your most valuable resource. Anyone here getting any younger? I didn't think so. So when you invest your valuable time to come to our events, we want to ensure that you maximize your ROI. We have lots of partners that help us do what we do: law firms, venture capital firms, angel investor groups, incubators, accelerators, colleges and universities. Tonight, we're grateful to Sherman and Sterling for hosting us at this beautiful venue. We've held many events with them, and we look forward to many, many more. They're a great partner, and we're honored and privileged to be collaborating with them. So let's hear it for Sherman and Sterling one more time. A few of our other partners are here tonight. I'm going to have them come up and say a few words. Let's hear it for Kay and the Silicon Valley Innovation Center.
Thank you, Rob. My name is Kay. I'm from Silicon Valley Innovation Center. We bring top executives from all over the world to the Silicon Valley and connect them with local ecosystem. So you startup guys with AI startups, if you have a product ready for the customer and ready to sell it to the big guys, talk to me. I will be around. Thank you.
Who's with the big guys anyway? Next up, we have Mike of CTO 911.
Hello, my name is Michael Lin with CTO 911. I've been helping entrepreneurs here in Silicon Valley. I offer CTO consultation services for entrepreneurs here, helping them build software, taking their business vision and idea, turning that into working scalable software. Anything from wireframe design, mock-up, to UX, usability, and then obviously to software development, implementation, QA, launch, right? Anywhere in that life cycle, I can definitely help you. If you need some assistance in that area, Michael Lin, again, I would love to talk to you after the event. Thank you.
So our local mission is to support entrepreneurs here in Silicon Valley. Our greater mission is to democratize entrepreneurship all around the world. To that end, we have a robust YouTube channel, youtube.com/idea-to-IPO. We have tons of videos. We document many of our events. And this rich content is available on demand, anytime, anywhere, totally free of charge, whether you're in Menlo Park, Maui, Moscow, or Timbuktu. Who's been to Maui? Who's been to Moscow? Who's been to Timbuktu? The point is, there's Wi-Fi in all these places, and anywhere you have access to Wi-Fi, you have access to the great content that we produce here in Silicon Valley. Because great entrepreneurs can come from anywhere, not just Silicon Valley. Our partner in this endeavor is Tim Jeggers of Jeggers Films. Let's hear it for Tim.
Thank you, Rob. So I'm Tim Jeggers. I'm the video partner for Idea.IPO. I manage the YouTube channel. As you can see, we have cameras set up. So about 4 weeks from now, tops, usually 2 weeks, if I'm not too busy, I upload the videos of all this. One request I have of all of you, I know you're probably going to have questions throughout the panel. If you could refrain from asking during the panel discussion and wait until the Q&A section from 8 to 8:30. We'd love for you to line up over here, come up, ask one at a time. That way I get better audio for the video because I only have recorders here and over there. So we're not going to hear anything you're saying out there in the video. Other than that, I'm just a video producer. I do content, photography, and partner up with people all over the Bay Area to produce content. Yeah, that's pretty much my whole thing. Thank you for coming and having us.
Tim also does weddings and birthdays, so if you have one coming up, see him and we can get you a discount. So without further ado, I want to get started with the program. We're actually going to have our panel discussion run till about 8:10, and then we'll take audience Q&A from 8:10 to about 8:40. And again, when it's time for Q&A, line up and hold your questions until then, and I thank you for your cooperation. So I'm going to pass it off to our distinguished moderator. He is a partner of this firm. He's one of the top intellectual property attorneys in Silicon Valley, and he really knows the stuff. So let's hear it for Richard Chu, attorney at law. And our panel.
Thanks, Ron. It's a pleasure to have you here and an honor to be able to host your very well-attended events here. Before I ask the panelists to introduce themselves, let me kind of just ask you as the audience, how many of you would say that you're really an expert or very knowledgeable about artificial intelligence? Okay, there's a few people. And then how many of you would say you know almost nothing about it? Okay, so I assume everybody else in the middle knows a little bit or something. I figured I only need to ask about the two ends. Let me ask, how many of you are currently, an entrepreneur or working at or have started an artificial intelligence company? Okay, fair number of those. And how many of you are thinking about starting an artificial intelligence company? Okay, so a few sprinkled there. And then how many of you would you say are currently researching or studying the field of AI? How many of those are there? Okay, so that's a fair number. Okay, great. So I'm going to ask each of our panelists to first introduce themselves and describe a little bit about what area of AI they're in, because it's a broad term. So with that, I'm going to start by asking Zvi Aklar.
Hi, my name is Zvi. I have a background in actually neuroscience and computer science, and my interest came from trying to understand the brain, what's in the brain that's not in the computer. Is it really like neural networks? Is it really like the machine learning? And then what are the practical problems that the brain deals with that the algorithms don't? And so my focus is to make AI explainable, because if people can explain what they are expecting to recognize, and also the brain is much easier to learn immediately. So from that background, I did cognitive psychology. I did actually electrophysiology, just to have a really good idea of the algorithms and the brains. Thank you.
Thank you. Sophia?
My name is Sophia Bicklund, and I'm a technology entrepreneur, serial entrepreneur, and I love starting companies. My current startup is using deep learning in a very interesting way, and also I'm a co-founder of Silicon Valley Deep Learning Group. Silicon Valley Deep Learning Group is about scientists, investors, students, and engineers that are learning about deep learning and sharing experiences. It's a professional organization that is a non-profit. And I see some people that from my group here tonight, and it's really good to see you guys. So my current passions are deep learning, and I believe that the current state of it is very important for the future for all of us. Also, in the past, my past company that I co-founded also used deep learning for self-assessment. It was about serious games. We did training and simulations for Fortune 500 companies. Also, I'm best known for being a co-founder of PyLadies, which was an organization that has expanded into 26 countries right now. And it's taught women Python because it's a human readable language, and lots of women are interested to learn it all over the world. Also, my background is in computer. My background is speech recognition and language pattern recognition. And I'm also passionate about the community, and I'm working with somebody like Rob tonight is really an honor for me because he's one of the best and biggest groups here in Silicon Valley. Thank you.
Thank you, Sophia. Ranjan?
Thank you. My name's, can you hear me? Yes. My name's Ranjan Nag. Thank you for inviting me to be on this panel. I've been working in various forms of AI for about 30 years, starting from my undergraduate electrical engineering project on speech recognition for phones. So I'm an entrepreneur, an investor, and an academic. I first started, was inspired by Star Trek, actually. If you're not sure what to invent, just watch a few episodes of Star Trek. And built the first speech recognition phones at Motorola, and then built first mobile app store. And my reputation is that the first company was bought by Motorola, the second company was bought by BlackBerry, and the third company, which was I was more of the investor and advisor, was bought by Apple. And I first came across neural networks in the mid 80s, and came to Stanford about 25 years ago in the psychology department. My PhD was in engineering, but I wrote this letter to the most famous professor in the field at the time, it was Professor Rummelhart, and he said, yeah, sure, come along. And he said, Department of Psychology. So I was a bit nervous, but it turns out he collected physicists and engineers and linguists, and basically started, I think we were pretty much the first neural network company to come out of Stanford in 1991, doing cursive handwriting recognition. I'm an active angel investor. I have about 28 companies that I've invested in, and advise many other companies. And I'm currently a fellow at Stanford working on a number of things, but particularly in the healthcare space for AI for healthcare.
Thanks, Ranjan. Ed?
Hi, my name is Ed Fernandez. I run a venture capital boutique here in Palo Alto. We essentially help early stage companies to raise capital in secondary stock markets. That's our main activity. Then we also help startups as advisors, and for that we are affiliated with Singularity University and Berkeley, the Center for Entrepreneurship and Technology. And more at a personal level, I've been interested in machine learning for over 1 year and a half, and looking into the space. Actually, for full disclosure, I am advising Dr. S.V. Atchler at his company, Optimizing Mind, which, by the way, I recommend you have a close look, because they have really something very interesting in machine learning. And I also became an advisor and an investor at BigML, which is also a machine learning company out of Oregon as well. In terms of credentials, I don't have any, other than an engineering degree, Rusty, so I am a Rust engineer. And in any case, if programming in assembler back in the time when the Commodore 64 was the PC of the industry, maybe that may qualify to say something here. But I hope I can provide also the business angle to the artificial intelligence and machine learning world, and a little bit about the venture capital overview here.
Thanks, Ed. So let me ask our panelists, let me start by asking you, how would you define artificial intelligence? It's a very broad term, but what does that word mean to you? And specifically, maybe comment a little bit on how that differs from some of the other terms we hear. You talk about machine learning, you mentioned deep learning, neural networks. What do those terms mean to you? What does AI mean to you?
So I think there's, AI is a very broad term, and there's two major separations. One is the machine learning, where the machine automatically learns from the data set. And the other set is like, I'll give it examples, statistical methods, k-nearest neighbors, and so on, where it's a little more designed, and the features are designed, and so on. What's been taking over lately has been the machine learning, and it's basically because of the acceleration on GPUs, and that's really what has blossomed in the last few years, and gives us all the great performance that we get from it.
Sophia, you want to add anything to that, or talk about deep learning? You mentioned that.
So I would like to say a few words about AI. I'm on the board of Entertainment Industries Council, and they deal with perceptions of women in media. So AI, and the reason I'm saying that because how this is perceived is AI is the future. It's something that is so broadly defined that it's basically a goal. It's something that artificial intelligence is something that is very human-like, and so if we could build that. And I'm consulting on the show right now that has to do with building of an artificial intelligence as an ideal man, as an ideal boyfriend. And that's what I'm trying to come to. And this is, there is no limit to what we can do in that show. So it is very much Hollywood oriented. It's more about what we think it could do. And the perception of it, as we see, is really broad. So I think AI is something that, as Dr. Tzvi pointed out, is again a broad term, and I think that. Oh my goodness, I'm sorry. I have a public speaking fear.
It's okay.
Sure.
Go ahead. Why don't you
Yeah.
talk a little bit about how you describe it? How do you see? How do you define it?
Okay, right. So I guess the cat's out of the bag, basically. Both in industry and the field, whether people use a lot of these terms interchangeably. So the technical definition is what both Tzvi and Sophia accurately suggested. So the technical definition is AI is can you tell the difference from a human? Does it embody human characteristics, human intelligence? But I see really in the field, even in the academic field, even in industry, people are using these terms willy-nilly, interchangeably. And then if you take a really cynical approach, say, well, once you've got a computer solving a problem, well, then that's not actually, it's proven it's not intelligent, right? So there is even that, there's the devil's advocate view. The term has been around for at least 50 years, and originally what people used to do was embody a so-called intelligence by writing rules. So classical computer programming, the classical one is ELIZA, where you had a therapist and you just ask questions and it would reply. Often it would reply what you said back to you with a question mark. And people would just write rules. And for many years in the 70s and 80s, there was a battle between an equal battle where the so-called rule-based systems and statistical systems. And the rule-based systems did pretty well in those early days. And then as you start getting more computational power, people came up with statistical techniques to sort of train automatically. And usually when people say machine learning, that's what they're referring to. And a subset of machine learning, there are many techniques, is a technique known as deep learning, which is basically a rename of neural networks. In the old days, neural networks are essentially, you can think of them as computational nodes which compute a very simple function, and they're connected together. And they're usually connected together in layers. And the reason they're called neurons, the connections have a weight, and you multiply the function by the weight, and the layers go forward across each other, propagate the computations. And deep learning in the olden days, in the early in the 1960s, they tried it with basically no layers, and a person known as Professor Marvin Minsky at MIT said this would never work. It won't solve these very complicated, what we call non-linear problems. But it turned out he was wrong, even though he's called the father of AI. But he set the field back about 10 years, maybe 15 years. Came back in the late 80s, and people said, "Oh, if you rearrange these networks a particular way with a layer in between, you can solve more complicated problems." And then now, fast forward to today, we've got computational power, we've got enough data. We can have many layers and many components to solve more difficult problems. But it's part of a class of many techniques that are used for the concept of AI. And what you have to talk about, do humans work like this? And Tzvi can probably comment. We can have a little discussion maybe in a minute. Do humans work like this? Because often we don't look at gigabytes of data. We just, once I've seen your face, I'll remember it tomorrow. So that's my comments.
Great. Ed, do you want to add to that? I know you said you're a versatile engineer.
Yeah, very quickly.
Want to add something to that?
Very quickly, when I started looking at machine learning and being a newbie, completely not knowing anything about machine learning other than very, very, very basic understanding, I also wanted to invest in the space. So I struggled trying to understand the language around the technology, and effectively I was looking at it from the application point of view. And for me, it was much easier to understand the technology by thinking of this as a kind of new software that is capable of defining their own rules. Simple things. I'm coming from the world where we were giving the rules to the computer to solve problems, and now we are moving very quickly into a world in which the machines are writing the rules for themselves to solve the problems. And machine learning in particular is about getting those rules from the data that is available. So the more data you have, the more those rules that the machine learning models will develop for themselves will be able or effectively delivering a solution to a problem. And that problems, or set of problems, are actually long-term problems that have been already there, like predictions or clustering or classification or many other things related to those basic problems. When you think like that, it's easier to understand the whole jargon around artificial intelligence. At the end, artificial systems or intelligent systems is a combination of those technologies towards a bigger purpose, as you have defined. So I guess that what was striking to me is how important this shift in the way software is going to be written, how important this shift is going to be in every single category. Then I started looking at the different clusters of applicability of machine learning, like what is happening in healthcare, what is happening in supply chain, in manufacturing, in fintech, in credit risk, all the different applications that are out there already, because this is, believe it or not, a null technology. And what I saw is that if you look at the numbers, what you will see is that we are living a phase of new efficiency driven by these machine learning driven softwares or applications. So you can think of this as like it happened in the past. In the past, we applied machines at industrial level to drive efficiency, and the industrial revolution happened. Now, to a certain extent, and with other limitations, but machine learning is driving a new wave of efficiency in literally every single vertical, one way or another. And then there are companies with different approaches towards that. There are tools manufacturers, there are tools of providing of tools, other different open source elements that you can use. There are visualization tools that you use in order to deliver those models. A whole industry is blossoming right now based on that.
Well, hey, that's a perfect segue, because I want to now move from the theoretical to the practical, and I wanted to ask you, what are some of the applications for AI specifically, and maybe talk a little bit about why those applications really lend themselves to AI. Obviously, it can be used in a lot of different things. It's probably not equally good for everything, but maybe touch upon that. Pick 2 or 3 examples, 1 or 2 examples of where you see AI really being good in practical applications.
I think AI is best in scenarios where you have big data sets that you can train computers on within a defined problem space, and you can crunch the computer on the thousands and millions of examples that will bound the whole space, and the AI will perform its operation within that space.
So what's an example of that?
So Siri, voice recognition, self-driving cars. What it may not be as good for, if I can, jump the other way, is things with a lot of variations where you can't nail down so much the right data set because things might jump around, or there's these extraneous cases.
What's an example of that?
Just learning everyday things as you see them.
Okay, Sophia? What are some of the practical applications of where AI is being used?
So the companies that I see in the Silicon Valley Deep Learning Groups network I see more niche applications, so it's less broad right now. So as in the past few years, the applications are narrowed, for example, to solving very specific tasks. One of the companies, for example, right now represents water efficiency detection, and they're used by municipal governments to detect, using deep learning, how water loss is happening, and that would not be human possible to know. For example, that's one of the applications. Also, I see a lot of healthcare applications right now to assess the data, to gather data for predictions of certain conditions, and also I see a lot of fintech for financial applications. I've had people come to me saying we'd like to have a startup that analyzes, predicts litigation if that's possible. It was one of the potential uses that these people are looking at, and I know they've got something going right now in regards to that. So I see as people take the technology and try to apply it to a variety of problems. I haven't seen oil and gas yet, but I think that would be also used, and I'm sure it's used right now. I think applications are basically unlimited.
Okay. Ranjan?
Okay.
What about you? Where do you see
Yeah,
AI?
I love AI because it's all, so I can come back to it any time, and there's always a problem to solve. And to some extent, we have applications that we keep working on, like speech recognition. I've been working on that for literally 30 years, and we've still got problems to solve. It's probably another 30 years left to get to where we're speaking like this together, where we understand each other, different accents, different noise conditions. So you see some classical extensions of the academic problem. So speech recognition is a classic academic test case. Undergraduates, graduate students, there's major data sets, people run those, and then there's a jump on whether you can actually commercialize that. So the devil's in the details. So areas in that space are speech recognition, handwriting recognition, which was my first company, and then you've got another set of spaces which are, I think, sort of verticals, which again have been, I would say, not in the classical definition, the way Sophia described it, where is it human, is it intelligent? Things like stock market prediction. I've got a company called Algo Dynamics that does that, predicts stock market crashes. There's another company, Sequester, that does face recognition in videos. So you've got regular face recognition in pictures, but then can you recognize it in videos? There's a competition called ImageNet, which is a classical academic test case, and you're now getting to the state where the performance is close to that of human performance. Then you're getting to applications where people are at least trying to replicate what you'd think are stronger human capabilities. So the AI doctor concept is out there, right? So in fact, Joe Biden reference to that in his interview recently, that they had the Watson guys come up with to find all the different kinds of cancer based on the set of symptoms. The AI lawyer, I guess we are we here? Are we in a law firm? I sent Richard an article which said the billable hour for lawyers is dead. Prepare for the AI revolution in law. And that's probably another ongoing discussion, which jobs are going to still be here in 10, 20, 30, 40 years' time. And then you're seeing the big guys have lots of good people, and they've got lots of huge data sets in speech, and Facebook is a major source of images, so they don't have to really collect data in the classical sense. So if you're a smaller company, what kind of application? So I'm seeing other applications very neat, like the strawberry picker application. Is Google going to build a strawberry picker? Unlikely. So a robot that picks strawberries. In the healthcare space, there's the dermatology space. Again, you've got to bifurcate sort of single use cases versus the AI lawyer type, AI doctor, which is much more integrated and where you're trying to sort of replace the interaction that a human might have. And I think the opportunity in AI is there are many, many, many verticals that are not picked over yet. And part of that is, it's a bit like, when the first Android phones, the first iPhone just came out, you couldn't find an iOS developer. Those people command very high rates. And you're getting that a little bit in the AI field today, but, Stanford deep learning neural network class, there's 400 undergraduates take that class, right? So it's all over the world. Every computer science department, every math department, every electrical engineering department have these huge classes teaching people some of these skills. And unlike when I came to Stanford 30 years ago, where I physically had to show up and talk to the professor and figure out, what are the secret techniques that are not published. Now you can download something called TensorFlow from Google, and you can get up and running over the weekend. And there's some other things like Big ML. You don't even have to write the code. So it's sort of democratizing the application. So my prediction is you're going to see a lot of verticals. And I wrote an article the other day, a few months ago, about a chief AI officer. Right, you're going to see companies that are. You see the NVIDIAs of the world, they're on the bandwagon already. Google's on the bandwagon. But what about Chipotle? What about JCPenney? What about, some of them have got sort of data science, but how do they actually graduate to the next level of functionality? I'll stop there.
Ed, what about you? You're a venture capitalist. You must see a lot of applications of AI.
I wanted to mention one, yes, expanding on what have been said. Are you familiar with Amy Ingram? Is anyone familiar with Amy Ingram?
I use it.
Oh, you use it? Okay, me too. So let me give you a little bit of background on this company, because they are effectively taking over the scheduler for us, for humans. So the company is called X.AI. They are based in New York. The CEO is called Dennis Mortensen. And they have an AI robot that essentially takes over control on your calendar. Once you provide access to your calendars and your email addresses, it will take all the job of scheduling for you. It's an email bot. You email with copying the people that you want to meet or arrange a call or Skype or whatever, and the bot will make everything for you.
We'll have a conversation.
Yeah.
It has a conversation. At least 50% of the people who receive it think it's a real human.
Oh, yes. That's right.
And she gets flowers and stuff.
That's right.
Yeah.
Oh.
Yeah.
This is an Andrew,
Yeah.
version.
Yeah, there is the main version, which is Andrew as well. And in the case of Amy, I know some friends of mine are asking her out and things like that, but okay. Well, let me, this is anecdotal, but it will give you a sense of how powerful these things are today. So I know Dennis Mortensen. I visited the company back almost 3 years ago. I wanted to invest in the company, but I arrived too late. They were raising already for 14 million at that time, if I recall correctly. So I met Dennis. I wanted to understand a little bit better their technology, how far they were in terms of deploying the bot itself. He was kind to offer me a subscription for the service to test it, and I committed to test it to the limit. Meaning, effectively, I was not talking myself with the people. I wanted to test the machine, including the errors, to see how far I could go. So, and this is actual data. I was able to arrange 13 meetings that happened in 4 days here around Palo Alto area, the Bay Area, all done by the bot. I didn't do anything else but picking and choosing the people I wanted to meet or I needed to meet. And we effectively came up with 13 practical meetings, all arranged by the bot itself. I was really impressed because if you try to solve that problem the old way, you actually need to have someone or hire someone to do that job. And that's no longer necessary. So I'm expecting the lawyers to be next. And I look forward to it in a certain way.
Well, I think there is this, Vinod Khosla is a well-known venture capitalist. His famous line is, look, if we can build a car that can drive itself, then we should be able to build a doctor, right, out of a machine. That's an easier task. And so...
but we have not built a car yet that can drive itself without creating security issues, and that may take 10 years. So you're mentioning it like it's...
That's true. That's true. I think that's a fair comment. You see a lot of headlines on lots of topics in this field, and then you have to sort of double click. Well, where are we really? right? Where are we really?
If I may,
Go ahead.
and to your point, and I believe this will be trigger a discussion also with Dr. Ashler, by the way. So, to your point about the problems we are facing with AI, and this is one of the drawbacks or the problems we see in how this technology is developing, the black box effects that we see in neural networks, those are like preventing things to happen. To your point, we don't know when there is a problem in when a self-driven car creates a problem, and you need to track how the neural network was taking the decision. There is these black box effects. We don't know very well how the weights were calculated, how the neural network was actually coming up with that decision, and that's a problem. Actually, and because we are close by, SRI has released a funding, DARPA funding, and SRI is working with them as well. So initially, the DARPA funding happened in August. This is $74 million that are going to be invested during 4 years to solve the explainability problems of machine learning. And this is about researchers working in delivering hybrid models that will be able to explain better how the neural networks are taking decisions. Actually, the expert here is not me. I'm just a nerd with our credentials, as I mentioned. But SV has a ton of work and experience for more than 10 years, as I believe, working on that particular part of artificial intelligence. So I think I hand over the mic to you, because I believe this is an exciting technology that is worth speaking about.
Thank you, Ed. Very kind. So, yeah, my interest is one of the things that humans can do that the machines can't really do well is to explain, what they were thinking, what did they use for that choice. And that's one thing that the machine learning algorithms can't really do. And because of that, when I developed my own version of neural networks, that is one of the key things I wanted to understand. How is the brain able to pull that information out, to learn but still be able to explain and not have that black box problem? So, and I want to step back a little bit. I want to give you an idea of what is the black box problem. Take, for example, Siri or Google. You say a word to it, it's probably going to recognize it, but in some cases, it doesn't. You don't have a way of saying, okay, Siri, let me type the word. What's the sound you expect? What are you expecting me to say? Because of the black box problem, you can't go back that way. And that's the same problem with self-driving cars when it's trained. If it's not doing the right thing, you don't really know why, what, and so on. And that's one of the major problems with the black box. And I believe once you figure out that problem, you can solve the second problem of, Google, I want you to add one more new word. Then that's going to be easier. That's another problem that the AI is not. You can't really personalize Siri to say, okay, this is how you expect to say the word. I'm going to tell you the word the way I'm going to say it, and please learn it that way on the phone. You cannot do that. That has to go back to Google or Apple, be retrained with all of the old and the new data. The one word that you are saying has to be retrained with all the old words that everybody else is saying to then get a new version to then put on the phone, so that it's not personalizable. And so I think that's interconnected with the black box. But the key with the black box is that you can't explain what it has learned. You can't ask it to say, okay, I know you know how to recognize this. What does this look like? What do you expect? And when are you going to say that? And if you do look into some of these algorithms that are performing really well, you'll be really surprised they're not really doing what you think that they're doing.
Let me ask a slightly different question. Ranjan, you mentioned that you grew up watching Star Trek. A lot of us watch Star Trek. Tell me a little about, is that accurate? Is the artificial intelligence you see on TV and movies like Star Trek, is that anything like what real artificial intelligence is, or is it just fake? Ed, why don't you start on your end?
Well, I think that there was an article about Back to the Future, how many of those predictions were coming through. I don't recall the statistics, but I think that it was like 60 or 70% of all predictions were actually happening, right? So I guess that everything we saw in Star Trek, like tablets and other communicators, are here. I think that the humans we are quite good at having the vision about the things that we need for the future. A different thing is when those are going to happen and how fast it can happen. Those that know when are going to happen are billionaires, obviously. The others, the ones that see that, are visionaries only. So I guess we can get a ton of inspiration from those movies in practical terms in order to understand what is happening around mobility. For instance, I recall the early movies when I started also in the mobile industry, when the phones didn't have internet access. But then you could foresee that at some point of time that was a computer that was capable of delivering data, and then you could have a smartphone in your hands. So all the early signs are there. And I guess that in artificial intelligence, everything that we see, we may debate about the timing of robots and other things, big things that are going to happen. We may debate about self-driven cars, but it's unquestionable that it will happen. The question is when.
Ranjan, you watch Star Trek. What do you think?
Yeah, well, let me clarify. We've got several versions of Star Trek for the youngsters here. So there's the first version, which was a fairly squawky text-to-speech computer, but the computer had you could speak to it and it could respond. And that first version, the Star Trek, I think at Motorola we even had a lawsuit on that, the communicator part. The second version, Star Trek: The Next Generation, I think the big difference, there was a robot that looked like a human called Data, for those of us who remember that generation. Sometimes when I talk to the young, I realise they're talking about the movie, they're not talking about the TV series at all. But when you have a robot that looks like that's probably the end goal, where you're having debates, is the robot actually conscious or not? Can the robot have ethics? And can understand everybody fluently and has an unlimited brain. We've got some of those components, but without the user interface. You have the web. You can look up anything in seconds, of course, now today. And so the part though is, can we get the transmission part, and can we get the interaction between humans and robots? And I still think, I think we concentrate, even though I worked on it many years, on this technique of neural networks and deep learning. I'm not completely convinced that's the end goal. That's the end tool. Some people think that's it's going to be a variation of that, but I think there's going to be other mechanisms and other tools that'll be popping out. It just so happens right now that fits the our computational resources. It fits our current framework. It kind of works. And what's very common is somebody spent 5 years on a PhD on topic X. People download TensorFlow in 3 months. They've beaten the PhD result. That's quite a common. That happens every quarter, pretty much. Some result comes out. So I'll stop there.
Sophia, you want to comment on that?
Oh, yes. So I've mentioned the show earlier, and also perceptions of women in tech. But now perceptions of AI in tech is also very important by public, because I fully agree with you that predictions that existed in Star Trek before, lots of them are true right now. It's possible to do, and the technology is rapidly developing. And for what exists right now in public perceptions of what technology is, applications are wide. And for example, if you were to build a handyman that could fix your door, for example, it's really hard to do even with current technology right now. So you could, basically the handyman as a person is really hard to replace at this time. with that is something that is yet to come, but the full dexterity of the embodiment of the AI, if it were to be embodied, is still quite far away. But to our previous discussion about, say, Annie Ingram and Andrew Ingram, that are bots that schedule your meetings, right now it's totally fully possible to replace humans in, say, call centers. And right now that's been done already. And more automation and development goes into, say, replacing bank tellers and lots of stuff, lots of other stuff that is developing, so we could automate more and more tasks that require remote interaction with the customer. But on the point of how AI is seen right now by the public, I believe that it still would be quite impossible to replace somebody like a good lawyer or doctor because of the personal interaction that happens. So if it's something close to you, if it's something that requires human touch or human interaction, it's really difficult to replace that, and technology is not there yet. So the future predictions would be building some machine that could possibly be as good as human, but then at that point it possibly could surpass the AI and go beyond that, and that would be something that we don't know yet. And I'd like to get your opinion about this for the future. But what I was the idea that I'm trying to convey is that I think that we could hopefully build a politician, a politician in the future that would be, but it would have ethics and other interesting, important features in it. And if that would be possible, hopefully in our lifetime, but I.
Let me ask. I'm going to change a different question. I have to start here. And since Sophia talked about it, we talk about Ed talked about replacement of people in a lot of AI functions. Is that something we should be afraid of? What do you think? Is that something we should be embracing? We're talking about driverless cars. What are your thoughts on that?
Well, I think in some cases it's still very far away. I think if you think of the system more as an assistant, kind of like, Siri is for typing on the phone, or, maybe a doctor app is for helping the doctor, choose some of the, the potential things. I see still the human, very importantly involved. But I see more and more of kind of assistant type applications becoming better and better and better. And yeah, maybe if they get really good at some point, but that I think that's still very far away.
Let me
far away.
Let me take another extreme. Let me take the opposite completely. I think be afraid, very afraid. I think it's not going to be next year, but if you look at the macro trends, not AI specifically, and this you can see the election and the last 10, 15 years since just before the smartphones coming out, sort of 1999 period, last 15 years, productivity has improved immensely. But employment is not. And the last time we had an industrial revolution, people basically, over a period of years, went off and did different jobs. So the factory revolution, and people went off and stopped becoming servants in people's houses. The Downton Abbey effect. You see that transition in the most recent seasons, where people are move from the service household service economy to factories. And that happened in the last revolution. That has not happened currently. So the debate economists ask, is it just hasn't happened yet, right? We are going to get people doing different jobs. We just don't know what they are yet. I would take a very pessimistic view on the employment aspect. There was even an article today on the radio about the concept of basic income, right? So we have so much productivity, so much automation that there actually physically isn't enough work to go to. And I think that trend is going to actually accelerate, because In the olden days, we had to basically build everything, the whole thing from scratch. Today, you have APIs for everything, so you don't have to invent every single thing. You know, Google solved the search thing, and you've got social media APIs, look at all your friends, and APIs to do that. And a lot of the enhancements to the speech recognizers today are really integrating into the Open Table database, into the Yelp database, into the Travelocity database. They haven't actually added anything functionally from a scientific point of view. They're just, and that's going to accelerate. You know, and I've got to ask, you know, can a doctor keep up with every? You know, there's millions of medical papers published every year. Can he have read all of them? Can a lawyer have read every single case law, every single patent that comes out to help their client? They're going to start off by using tools, and you know, sometimes you can ask, you know, who's got more job security, the neurosurgeon or the nurse? So my bet is the nurse, right? Nurse, obvious. There'll be fewer. I mean, neurosurgeon, that's pretty smart, but you'll need fewer of them, right? That's how it's going to start. You're going to need fewer people who are doing these things. And so, yeah, I guess I'm painting the picture. But then the opportunity is, maybe we've got more fun things to do than work. That's the opportunity.
So let me, since we're running out of time, I want to ask one last question, and then I want to turn over to questions. And we'll start with Ed. And that is, you've probably heard that famous quote which says that people tend to overestimate the amount of change that will happen in 5 years, but they tend to underestimate the changes that will happen in 20 years. So I'm asking you to predict the future here. Name a few things that you think will be different in our lifetimes that aren't currently being done today. Start with you.
Okay. So
by AI,
years,
of course.
okay.
By AI.
So maybe following a little bit on the jobs problem for the future, my prediction, and I may be wrong, but my prediction is that everyone under 25 years old will have their own startup by the time they get to 25. So my children will have a startup. They may have other jobs or other ways, but I believe that because of the effects of automation and artificial intelligence and you name it, we may need to be more liquid in the way we work. No longer like the typical traditional employee relationship to a corporation. That, I believe, is going to change a lot and very, very rapidly. Why I believe that's the case is because, to your point, I can now rely on APIs and other services to do part of the things I need to professionally. My team, we work it's a small team, but we work completely remotely. Everything is in a way automated in terms of collaboration with different tools, and some things are starting to be also automated. Like, for instance, when we want to make a due diligence of a startup, we used to have we have our senior analysts that will take a thorough overview of the startup. Now, this guy from BigML came up with a product called Precision that will score the startup for you and give you all the information. A work that for an analyst was taking like 3-4 hours is now done in 10 minutes. So same thing for everything. There is an API for this, there is an API for that, there is services all around that the tasks we have in front of us become automated. And with that, the way you need to actually convey that to your customers is also automated in a certain way. So my prediction is that we will start working that way. And that for new people, for younger generations, is going to be about actually building their own professional service or their own startup.
Ron, 1 minute. Go.
1 minute.
I want to get everybody to that question, so 1 minute.
Okay, all right. So I think there is opportunity, as Ed said, and I'm looking to a rosy future where everything's done for me and I don't have to do any work.
All right, that's pretty good. Sophia?
I think that when I hire for my company, I look a lot of soft skills. So that's in young engineers that graduate from prestigious universities. It's really important characteristic to have, because through that they could actually succeed more than just being technically perfect. And as we know, robots will program really soon. Also the robotic nurses, by the way, there is that development right now. It exists at USC, robotic nurses, and lots and lots of other automation that will go into place. And especially right now, as I mentioned before, the niche developments for lots and lots of other industries that also would be affected by AI and deep learning. So I think people developing the human side, connecting to each other, and developing their personal skills in a soft way, it's really, really hugely important. So if somebody young, and I mentor at Caltech and other organizations, and I tell engineers, I say, please, you have to be good with people. You have to be good with people, and that's your ticket to success. And then no AI could beat you, because you're still going to have a lot of productive future in life in front of you.
Zvi, last comment.
I actually agree with Ed. I think the kids will really know how to use this way better than we will. They'll be much more comfortable with it, and it'll be more second nature, and they already can do it much faster on the tablets, and you see little 4-year-olds doing all sorts of stuff. So, yeah, it's going to be a little hard for us. But I think overall, we'll see from the kids on how to use it well and efficiently.
All right, very good. So now, with that, let's turn to audience questions. I think Rob says he wants people to come to the microphone because we're recording it. So if you will come to the podium and just line up in a queue, that'd be great. And when you pose the question, I kind of maybe suggest who you'd like to ask to, or if you want the entire panel to ask. We don't necessarily have to have everybody respond to every question, but if you have a specific question for a certain panelist, please feel free to articulate that. So go ahead.
I have one question for C and one question for Ranjan. So C, you have mentioned about the black box problem. Right now, if you look at image recognition using neural networks and deep learning, if you look at some of the layers, they do mention about how the contours of your face, for example, look like. So it is in a way how you are asking machine, you're asking machine how it thinks. So do you think that is sort of making machine explain how it thinks?
Yeah. So I think there's progress in that. So most of the progress is in convolutional layers, which are layers where you kind of run a filter throughout the whole image, and those can be a little better explained. The other progress is to look at the gradients and try to see how you take an existing image and modify it a little bit. But I think there's more and more development. For example, we're able to take an existing network, convert it to ours, and then explain what each node is looking for, what its ideal pattern is, and throughout the whole structure. So including the deep and the fully connected layers. So I think that's part of the answer, but we could do much better.
We actually hold off on your second question. It's a long line, so one question per person, you come back at the end. Oh, next please.
Hello, my name is Rufo Guerreschi. I'm CEO of Trustless.ai. We've been talking about this issue of the black box, and I'm not knowing about what the algorithm are doing and trying to explain in human way what it's doing. And of course, having been able to look at the code of what it's doing. There's a problem though that the complexity of AI is just so large that the algorithm structure, recurring, and just the size, that really may be impossible even by looking at it, being able to explain, to know what it's doing. Like just Linux and open source, you can look at it, but a million lines of code and you cannot do it. So transparency may not be enough. You need also like a level of complexity which is reduced to do that. And so that makes it impossible. So basically AI is just like our mind. There's no way you can predict it. The only way you can keep it under check is by having your conscience, which regularly, or at least in good people that do meditation regularly, checks on it, and you have value system to check on it. So there's really no way to control it.
Yeah, let me comment.
Yeah.
It goes back to my earlier comment a little bit. So I think, as V said, you can get some, you can look at nodes and you can look at layers to see what they're doing, some basic things. But eventually, if you've got these networks with, a million nodes, and by definition, if the problem is complex, and if you can write it in 3 or 4 rules, you're not going to need a very complex set. But by definition, these problems are so difficult. There might be thousands of rules. Fine, I can write them down. Is it very useful to you to look at those thousands. And it goes back to my earlier comment where the cynic would say, well, okay, if you can actually solve the problem, well, actually it's not that intelligent. It's not intelligent in the first place. And so it may be a balanced thing where you can get some basics, but to get thousands of things might be too difficult to assimilate.
And I also wanted to address that question. I actually disagree with you a little bit. I mean, I agree with the forms of the neural networks that are used now, which are feed-forward methods. And I'm trying to avoid some of the details. You are always going to have that problem of a black box. But the brain is different. It's using feed-forward feedback connections. And you can do recognition not with feed-forward networks, with a different type of networks. For example, the type of network that we use, which is feed-forward feedback, and it's constantly doing this evaluation of what of it, the things that it's learned fits better, or what of a combination of things fits better. And when you look at that whole problem from that perspective, then you can explain it. And the key is we're able to take any feed-forward network and convert it to ours and run it in that form. So I disagree in certain types of networks, especially the ones that are feed-forward feedback, you can. But I do agree that in the type of networks that we use, the feed-forward networks that are predominantly used, you can't really do that.
Okay, next question.
Hello. So I have a twofold question. I'm Mayur, by the way. I'm the co-founder of company Glib. The question that I have is, knowing that this market is very crowded, knowing that 5 to 10 years from now, a lot of people, a lot of companies will be doing AI, a lot of people will be using AI technologies. What's your vision for an ideal, successful AI company?
You have any specific person you want to ask that to, or you want
anyone who has some differentiating points.
Ed, yeah, I think that sounds a bit like your alley.
Successful or
so
economic.
If I understand properly the question,
Yes.
most likely it's about how to make a startup successful in the realm of AI, right? So basically, how do we differentiate with API or AI? The long term, 5 to 10 years from now. Okay, let me give you straight the investor perspective.
Sure.
There are bad businesses and good businesses. Any investor will look for good businesses. So this is no different than other, from an investor point of view, and I'm probably, I need to be a little bit generalistic here. Investors are looking for problems that are solved using a stack, a technology stack. When that technology stack touches machine learning and other technologies, we call it AI or something around those lines. But it's a simplification of the problem only. I think we don't need to be stuck on the language itself. The important thing is to understand properly what that solution, that technology stack is solving. And if it is a good business, you will get investment and you will get the capital to run the company. This is no different than what the internet did some years ago, or other technologies like mobile or cloud, or we may want to call it AI, that's fine. We may need to agree on the language and be precise on what we mean by machine learning against AI and things like that. But essentially, it's technology applied to solve problems.
Yes, and also I could add to that if you have a good product and if it could be monetized, so if it makes money, yes, investors want to invest because financial predictions, but also users and your ability to monetize your idea is the most important. It doesn't matter if you use which machine learning parts you use, and so it's still very much based on your success in the market and customers buying your product.
Alan? I hope you're going to ask them, are lawyers going to be replaced by robots? I'm hoping you'll ask that question.
Well, I wanted to, so I'm a partner at Sherman & Sterling as well. Okay, no applause for that. I just want to pick up on something Ron John was talking about, the idea that, you get more technology, more artificial intelligence, and that will, give everybody more leisure time and, you can just do what you want. I mean, I'll probably get the facts wrong, but, there were studies done decades ago where people said, the biggest problem that we're going to be facing today is how we're going to use all the extra leisure time, and people had predicted that work weeks were going to be reduced to 18 hours And as we all know, it's kind of gone the opposite direction, that everybody's working harder, there's more stress. And, and to your point, Richard, I mean, if you look at lawyers, now everything, documents, you can send things out by email, you can do a compare write in 2 seconds, where it used to take, 3 legal assistants, 3 days to do it. And there's the expectation that you just have to turn things much more quickly. And I think that applies to a lot of other businesses. So in some sense, technology, we're almost becoming slaves to the technology because the expectations become higher. And then, you've been talking about, replacing, that AI can replace doctors, can replace drivers, can replace, all kinds of human interactions. My question really is, at some point, is that going to kind of come around full circle, and people are going to step back and say, well, wait a minute, we're humans, right? We're kind of missing out on the human experience. I want to talk to a person. I want to have a human interaction. I think you're going to see, I think you see it now with all the kids on the tablets, that their brains are getting scrambled up by it. I even feel myself in the last, since we started using BlackBerries and smartphones, your attention span, it's harder to really focus on things. And I think, applying it to AI, if all the interactions are done with some of the artificial intelligence, at some point, aren't people going to say, enough, I'll pay a premium if I can talk to a person. When you see that now, sometimes, when you make phone calls and you want to talk to a person, not a machine, I would think that it could get greater to the point where it's going to tip over, and people say, I don't want the AI, I want people. And you might have businesses that are, marketing themselves, say, hey, come to us and you will see a real doctor, not a machine. And so it might come around the other way. What do you guys think about that?
So that's, you're seeing that in some fields already happening. I think some airlines will charge you more, certainly in Europe, they'll charge you more if you actually want to speak to the real person, and then often people don't speak to it. Most of when they have that scenario, people do use the web when they can. I think the issue is, people go to the lowest cost, best service, and so let's take the doctor example. There's a book out by Eric Topol, and the title of the book is "The Patient Will See You Now." Right. So the implication is the patient's doing all their research. They get they put their symptoms in, and they just need to talk to a real person just to double check, and the doctor has to prescribe it. Often you need a doctor for one thing, for prescribing the medicines and things like that. And so you're going to find maybe that sort of barrier of industry where people are doing the more efficient part. I'm seeing that already. I spend 2 hours researching it. I get 10 minutes with my doctor, but that's all I need now, right? And now the doctor's expecting you to have researched it beforehand. So she says, what do you think it is? right. You've spent 2 hours, but you just don't know all the terms, right? So I think you're going to get a little bit of, you're going to get that efficiency. And I agree with you. People do desire human contact, but are they willing to pay for it?
Okay.
Yeah.
I'm trying to get through everybody here. We have 10 minutes. So
I have a question about what's really latest in language understanding. We get a lot of hypes, virtual doctor. It won't happen like in the next 4 or 5 years, of course, but reality check. Where are we with language understanding? The current method is we use annotating data more like a robot or like an animal. What do you see the future? How deep learning can escape the trap of data hungriness? Where are we really with language understanding?
That's a good question.
Well, I can answer that because I know this person from my deep learning group, and he has an innovative bot company, chatbot, that is actually really, really efficient. So I think you would be the best person to answer that question. Because I think you've been really successful with your company recently. You guys working with ideas. I know you guys gotten, and the future of chatbots right now is really, really gigantic. So you could
let me add a comment, because many people mostly
speak in the microphone.
Like this.
They can't hear you.
Don't get too close.
Don't get too close. This is the right.
Yeah, thank you. That's good.
Many people thinking nowadays deep learning equals AI, which is nonsense. And we have a lot of statistical approaches which solves mostly the data, sound, etc. But what's really going on in language understanding? We see big promises, but where are we now? What do you think is a question to everyone?
Somebody want to
where are we in language?
We probably can't have everybody answer, but somebody can take the lead.
Yeah, of course, everyone who wants to.
Well, I can speak to the first part of your comment that yes, there's the machine learning, and then there's the other methods, the statistical methods, and we talked about the one part being a black box and not easy modifying. The other one is easier to modify, like the statistical methods, and easier to understand too. The problem is one is more scalable than the other.
You're talking about statistical methods.
Yeah.
Only.
Yeah.
So symbolic methods in AI.
So the kind of the statistical, the k-nearest neighbors, those sort of things, they aren't as scalable as the machine learning methods, which are using the hierarchy. So you have this kind of balance of two sides. One, you have this method that can take a lot of huge data and crunch it and come up with something, but then it's a black box and you can't really understand what's going on, and you can't really modify it. And then you have the statistical methods where you can take in and modify and understand a little better what's going on, but then they can't take as many nodes and so on and as complex of data. So you kind of have those two sides weighing off. And
what about the symbolic side?
So I think symbolic is trying to overcome the black box. Yeah. Once you're able to overcome the black box, then you're truly symbolic. And so what I'm going to use as definition for symbolic here is you have a node. It says this is a car. Symbolic would be to be able to take car and then say what are you expecting in a car. That sort of thing, the symbolicness is part of the overcoming of the black box. And currently, the best methods to overcome the black box are actually the statistical, the k-nearest neighbors, those sort of things, but they're not as scalable. And so they haven't caught on like the machine learning part that is able to crunch all of these data and figure things out. So the performance isn't as good. So you have that the balance of the two. And what I argue is that once you figure out how to do the black box in the machine learning algorithms, then you can surpass. Then you have the best of both worlds because you have both the scalability and the explainability and modifiability.
Okay, let's move on to the next question because we have 5 minutes. I want to give everybody a chance. So if you have a next question, you can feel free to talk to the panelists afterwards, but I do want to give everybody a chance. Go ahead.
Okay, I have a question about applications. So I used to work several years at PayPal where we experimented using text analytics to read hundreds and thousands of customers verbatim. So we managed to, one specific use case is we analyze whether a customer say I will close my PayPal account, whether they actually close it. So we analyze that. But my question today, coming to this topic of what are the latest things. So let's say for a banking or fintech area, what would you say to a banker or divisional head of a bank on what are the feasible techniques, AI or machine learning techniques or application that is applicable today, not in the future, that he should think about applying in the banking or fintech area? What are the specific technique and algorithm in AI or machine learning? Thank you.
Quite simply, one of the biggest acquisitions in the AI field in banking was Heck Nielsen for 1.5 billion, probably about 20 years ago, which basically just did credit scoring. It basically did credit scoring of loans. But if I was the chief AI officer of a bank, I would extend it further than that. The customer support areas, similar kind of thing to your PayPal example, where people. I've heard a story in a company, which go unnamed, where they've got people like tagging every single customer support email. Is this a complaint? Is this a compliment? You can use machine learning to solve that problem. To label a few of those. So those are probably the two areas I would look at: quantity and customer service.
Okay, we have time for 2 more questions. Who's next? I think the line. Yeah.
So my question is around kind of very long future. I'm sure you're familiar with some of the dangers that like people like Elon Musk and some other are talking about, the AI becoming so much more intelligent than humans that we will become their pets. So my question and the solution he suggests, yes, that's a good scenario, exactly. So the solution he's suggesting is that we'll need to get like augmented in a way that we can think faster or input information faster. And my question is, do you see a future where we don't have to get augmented, we are just humans and interact with the AI technology, or do you see those augmentations as simply maybe like we're wearing glasses today, or it becomes like so common that it's something that we don't even notice? Do you have thoughts on that?
Well, if you think that intercontinental missiles right now are, could wipe out all of the population of the Earth, and who's controlling that? It's not AI, it's a human. So I think we should be very afraid. In the current situation, we may not have a future 5, 10, 20 years ago if that happens. So we do have a human responsibility right now over certain aspects of our society, because augmented or not, we possess tremendous power, every country does, to self-destruct. And that is, I think, is a very important issue to the whole world.
Okay, last question.
My name is Violette Abtahi, and at our startup, we are looking at designing patterns and architectures and applications of AI that we think are of priority and importance for today, which happens to be the ecosystem of Earth and the human race, which are both a danger from some perspectives if we look at them. In order to do that, what we have found out is that we need a parallel vision, and we need to implement some of the natural intelligence into the artificial intelligence world and technology. And what I mean by that is, as a human nervous system, we have our emotions that filter some of us, and some of us don't pay much attention to it, in order to go the right way. And so what you said doesn't happen. We have that even at a level of a broccoli or a pine cone intelligence and the Fibonacci that stops it so it doesn't grow as large as this room. We don't see that in technology. We don't see a big architecture or a big structure that is going to make sure that we're going to move towards the right direction, which is the evolution. So do you guys, and what I come to these events for is to hear what is happening in that area so we can talk to the people who are actually working on that. That's the control problem. Less than a dozen people, like the Nick Boströms of the world, are working on that. What do you guys see? What kind of, maybe this question is for you, coming from a combination of academia and many other perspectives. If you can maybe elaborate on that a little bit.
Right. So I think it goes back to my other comment that it is actually, it's a very difficult problem. It's a so-called integrated system, as you outlined, which takes many different elements from many different places. So my prediction, and over the next 10 years, it's going to get easier and easier, because there'll be an API for everything. So you don't have to invent everything from scratch, right? So there'll be an ecosystem world, and it could be a little startup, two people who have built a little widget that does topic X, and another person, and then Google does topics A, B, C, D, E, F, G, and H. And then the innovation would be, what do you want to integrate? Do you want to make a doctor, a lawyer? Do you want to just make a friend? Do you make it? And so I think my prediction is it's the grand vision as you describe. But I think you're going to get that. It's going to get easier over the next 15 years. You have things like sentiment analysis. People are using it for like commercial purposes, but if you adapt it to non-commercial purposes, then you'll be able to get other integrated systems.
Okay, one last question. This gentleman's been waiting patiently. Last question. This is the last question. Go ahead.
Thank you for the opportunity. My question is, or in fact, my understanding of a lot of the work that gets done in machine learning and AI really is based on trying to solve specific problems, right? To focus on them, to get some specific data set that applies to that problem, and then be able to find an algorithm, find a combination of algorithms, and so on. On the other hand, when we're thinking about human intelligence, really, to me at least, it seems that we really should be talking about a more general framework of learning, right? The ability to learn. And the question is, what is the state of the art, so to speak, as far as coming up with a general purpose learning framework, as opposed to AI methods and tools and systems that really address particular problems? So maybe you could comment on that.
There's actually a field organized around that. They call it AGI, or artificial general intelligence. The truth is that most of the applications are what they'd call, specific AI or narrow AI, where, like you say, you train to a specific problem. I think if you want to become more general, I think you have to solve some of the problems that are in the current algorithms. One is that you have to retrain on all the old and the new. In other words, and I'm using kind of technical terms, humans are able to do like one-shot learning. And so they see something once, they learn it. When they see something that's similar, they can kind of pick up on that. And the machine learning can't really do that very well. It needs to have a statistical interleaving of all the training examples and so on, so that makes it really hard to be able to do something like that. So kind of turning that around to answer your question, you'd have to overcome, number one, a couple of things. One of them being the one-shot learning. Another one being the black box, because humans, even if you see something once, and you know what, you learn it, you can then describe sort of what it was, even if you're not, things are hazy, you can still describe it, and if you're talented, you can actually even draw things from memory, and that's the black box things that you can't do with the feed-forward algorithms. So I think those are the keys to be more human-like.
Okay, well, it's been a fascinating conversation. I really appreciate you guys. Please thank our panelists. I'd love to have you come back in 25 years to see if we can get this get through. Thank you very much.
I want to thank our panel and Richard, and I want to present them with the classic idea of the IPO coffee mug.
Oh, wow. Wow. Thank you. Good.